Hello everyone. I'll speak in English since we have colleagues who are not from Serbia and not speaking Serbian. So, hello everyone, ladies and gentlemen. Today I will talk about very interesting research. The title is Modeling of Solid Biomass Down-Draft Gasification Process using Aspen Plus software package. I will pass through this presentation by following these topics, let's say, short introduction and then solid biomass characterization, something about Aspen Plus model, results and discussion, and in the end, of course, conclusion. So let's start. As always, in the beginning of every research, it is important to define subject and objective of research. So this time it was down-draft gasification of solid biomass. Two types of biomass. The first one is wood and the second one is wheat straw. So biomass was mixed with gasifying agent. First air. And in the first case, air, and in the second case, it was mixture of air and steam with different fractions of steam in the mixture. So 5, 10, and 20% of steam in the mixture. Objective of this research was possibility of utilization of previously developed model. I was developing model within my PhD thesis. Wood chip gasification process, down-draft gasification, and the idea was to change fuel and to test with different fuel and to test it with different gasifying agents. So the idea is to determine composition and low heating value of the generated, let's say, new gas this time, and also to see the efficiency of this conversion process. So the first thing was, since I've been using two types of biomass, as I said, wood and agricultural one, to do biomass characterization, so to define proximate and ultimate analysis of both samples, sample S1 and sample S2. So here you can see characterization of both. Then when we come to defining the Aspen Plus model, like in every model you have some assumptions. So this time it was considered that the whole process is steady state and isothermal, that the final products actually composition of the produced gas actually consists of CO2, CO, H2, H2O, CH4, and actually nitrogen, N2. It was assumed the char only consists of carbon and ash. Ash is inert and it isn't involved in any chemical reaction, and tars is assumed to be negligible in the producer gas, and also some other actually products of the down-draft, not down-draft, but in general gasification. So here you can see there were 4 blocks within the simulation in the software package Aspen Plus. The composition block, gasifier block, filter, and heat exchanger. So the composition, biomass decomposes in the constitutive elements. In another one, we model chemical equilibrium. The third one actually has a role to separate gas-solid phases, and in the end, heat exchanger, wherein actually the heat that is produced in the process is used to heat the water from 22 degrees to 100 degrees. So in Aspen Plus it looks like this. So yeah, you can see decomp, gasifier, filter, and so decomp, gasifier, filter, and heat exchanger, these blocks. And in these boxes, these squares, you can see actually the streams. We call it streams, so streams and blocks. Here you can see the input parameters for both biomass samples. So it was necessary to define fuel consumption, ER, syngas outlet temperature, chemical equilibrium temperature, as well as air inlet temperature and steam temperature. So here results are presented. First, production gas composition. This is the diagram where you can see results when wood chips is used as a fuel. Then you can see the one when wheat straw is used. Production gas LHV, low heating value, flow rate and total heat for both samples look like this. So you can see the both views. First is wood chips, the second is wheat straw. Also the next one, the previous was LHV, this one was production gas flow rate. And on the third one you can see the total heat. So from these diagrams it can be said that when the fraction of steam is increasing, actually CO2, H2O and H2 are increasing, because by adding steam into the gasifying agent, actually we have more hydrogen, so additional amount of hydrogen, and when the fraction of steam increases, CO and CH4 are decreasing, and it's explained by domination of CO2 formation and the composition of CH4, of methane. Also, by increasing the fraction of steam, low heating value of the produced gas, of generated gas, and total heat energy are decreasing. On the opposite, producer gas yield is increasing. And it could be said that wood chips is more convenient when it comes to production of heat. On the opposite side, wheat straw is more suitable for additional power production. And as conclusion, it could be said that this Aspen Plus model that was previously developed and tested for different kinds of biomass and different kinds of gasifying agents is a good comprehensive tool to predict characteristics of the gas, and also to implement it within similar CHP systems with CHP units with down-drop gasification process. Also, selection of raw materials has a high impact on producer gas composition, and also low heating value, and also impact on ratio between heat and power that is produced in the process within the system. And actually the third one is the third conclusion is that by adding the steam into air and into mixture of air and into air, so having a mixture, actually it has a huge influence on composition. So CO2, H2O and H2O are increasing, and CO and CH4 are decreasing, sorry. So that's for me. Thank you. Do you have any questions?
Ako nema, hvala Ivani na prezentaciji. Sledeći rad u ovoj oblasti je